Assalamu alaikum. Bismillahirrahmanirrahim. Punjab University MSc Mathematics Part 1 Past Papers. Real Analysis Paper 1. Question number 1. Suppose S is a non-empty set of real numbers which is bounded below and let alpha greater than 0. Then prove that log f alpha s is equal to alpha log fs. Question number 2. Prove that if x greater than minus 1, then 1 plus x की whole power n greater than or equal to 1 plus nx. Question number 3. Show that the series summation n is equal to 0 to infinity 1 over np convergence when p greater than 1. Question number 4. A sequence of real numbers is convergent if and only if it is a Cauchy sequence. Question number 5. Prove the following by applying the definition of limit of a function. Limit x approaches to infinity minus 1 की power x multiply by x over x square plus 1 is equal to 0, and also find the value of corresponding delta. Question number 6. Show that if a function f ratio a comma b approaches to r is uniformly continuous, then we can extend it to a function f की bar that is also uniformly continuous on a comma b. Question number 7. Show that every continuous function on a closed and bounded interval ICR is uniformly continuous. Question number 8. Let A subset are equal to R and f ratio a approaches to r has a limit at c belong to r, then f is bounded on some neighborhood of c. Question number 9. Let I subset of r be an interval and let f ratio I approaches to r be strictly monotone and continuous on I, then the function g inverse to f is strictly monotone and continuous on j colon is equal to fi. Question number 10. Let f colon 0 comma infinity approaches to r is differentiable everywhere. Assume that limit x approaches to infinity function x plus function dash x is equal to 0. Show that limit x approaches to infinity function x is equal to 0. Question number 11. If suppose f is a bounded function on a comma b, then show that to everywhere greater than 0 there corresponds delta greater than 0 such that u p comma f lesser than interval a to b function dx plus e. Question number 12. Give an example to illustrate that all of the hypotheses in the Nice theorem are essential. Question number 13. Consider the sequence fn curly brackets defined by fn x is equal to 1 over 1 plus x की power n. For x belong to 0, 1. Find function x is equal to limit n approaches to infinity function nx. Show that for 0 lesser than a lesser than 1, fn curly brackets converges uniformly to f on 0, a. Show that fn doesn't converge uniformly to f on 0, 1. Question number 14. Show that the function fx is equal to n square x 0 lesser than or equal to x lesser than or equal to 1 over n minus n square x plus 2n 1 over n lesser than or equal to x lesser than or equal to 2 over n 0 2 over n lesser than or equal to x lesser than or equal to 1. Question number 15. Suppose phi is a strictly increasing continuous function that maps an interval a comma b onto a small a comma b. Let alpha is a monotonically increasing function on a comma b and f belong to R. Alpha on small a comma b. Define beta and g on capital A comma b by beta y is equal to alpha phi y comma gy is equal to f phi y, then g belong to capital R beta, and integral a to b small g d beta is equal to small ab interval f d alpha. Question number 16. Test the convergence of integral 0 to infinity dx over 1 plus x की 4 sin square x. Question number 17. Prove that a function f is of bounded variations can be expressed as a difference of two monotone increasing functions. Question number 18. The function f is defined on open interval 0, 1 closed interval by function x is equal to minus 1 की power n plus 1 into n plus 1 1 over n plus 1 lesser than or equal to x lesser than or equal to 1 over n comma small n belong to capital N. Show that integral 0 to 1 function x dx doesn't converge. Question number 19. And define supremum and infimum of a set. Find the infimum and supremum of the set E is equal to curly bracket x belong to capital R colon x square lesser than or equal to 5 curly bracket close. Question number 20. Define an ordered field. Show that in every ordered field capital F comma x comma y comma z belong to capital F, semicolon. We have 1. If x greater than 0 and y lesser than z, then xy lesser than xz. 2. If x lesser than 0 and y lesser than z, then xy greater than xz. Question number 21. If p greater than 0, then limit n approaches to infinity, p 1 over n is equal to 1. Question number 22. Discuss the convergence of the series summation n to infinity is equal to 1. N is equal to 1 to infinity. Sin nx over 1 plus n square. Question number 23. State and prove the Cauchy condensation test. Question number 24. Examine the continuity of function x at x is equal to 1. Function x is equal to 2x if 0 lesser than or equal to x lesser than 1. 3. If x is equal to 1. 2x if 1 lesser than x lesser than or equal to 2. Question number 25. If f and g are continuous real functions on a comma b which are differentiable on open interval a comma b, then there exists a point x belong to a comma b at which fb minus fa g dash x is equal to gb minus ga function dash x. University of the Punjab MA MSc Part 1 Supply 2020 and Annual 2021. Subject Mathematics Old and New Course. Paper 1 Real Analysis. Time 3 hours, marks 100. Note: attempt any 5 questions in all, selecting at least 2 questions from each section. Section 1. Question number 1A. 1. Let x comma y belong to real number and x greater than 0. Prove that there exists small m belong to integer positive such that mx greater than y. 2. Let a and b be two non-empty bounded subsets of real numbers. Define a minus b is equal to curly bracket small a minus b comma small a belong to capital A comma small b belong to capital B curly brackets close. Prove that supremum a minus b is equal to supremum a minus infimum b. B. If R is a non-zero rational and x not equal to 0 is an irrational number, prove that R minus x and R over x both are irrational. Question number 2a. Let capital X colon is equal to x and curly bracket and y colon is equal to y and curly bracket be strictly positive sequences, and suppose that the limit lambda is equal to limit n approaches to infinity x and over y and is not equal to 0 exists. Show that the series summation xn and summation yn converge or diverge together. B. Prove that every Cauchy sequence of real numbers is convergent. Apply this to check the convergence of the sequence xn curly bracket defined by x1 x1 colon is equal to 1 comma x2 colon is equal to 2 and xn colon is equal to 1 over 2 xn minus 2 plus xn plus 2 from for n greater than 2. Question number 3a. Let A subset real number and f ratio A approaches to R let C belong to real number be a cluster point of A. Show that 1. If limit x approaches to C function x is equal to L, then limit x approaches to C function x mod is equal to L. 2. If function x lesser than gx, then limit x approaches to C function x lesser than or equal to limit x approaches to C gx. B. Show that every continuous function in a closed and bounded interval I attains an absolute maximum and an absolute minimum on I. Question number 4a. Show that a function f is uniformly continuous on an interval a comma b if and only if it can be defined at the endpoints a and b such that the extended function is continuous on a comma b. B. Evaluate the following. 1. Limit x approaches to c. X की power c minus c की power x over x की power x minus c की power c, comma c greater than 0. 2. Limit x approaches to 0. 1 over sin x minus 1 over x. Question number 5a. If a comma b is a point in the domain of a function fx comma y such that 1. fx fy, fxy all exist in the certain neighborhood of a comma b. 2. Function xy is continuous at a comma b. Show that function y x a comma b exists and is equal to function xy a comma b. B. Find the nearest and furthest points on the surface x square plus y square plus z square is equal to 1 from the point 1, 2, 3. Page 1 of 2 page turn over. Section 2. Question number 6a. If f belong to R alpha on a comma b, then show that f mod belong to R alpha and integral a to b f d alpha lesser than or equal to integral a to b f mod d alpha. B. Show that every continuous function is integrable. Given an example to show that the continuity is only a sufficient condition for integrability, not necessary. Question number 7a. Show that integral 0 to infinity sin x over x dx is not absolutely convergent. B. For what value of n the improper integral a to b dx over x minus a की whole power n converges. Question number 8a. Prove that the sum as well as the product of two functions of bounded variation is also a function of bounded variation. B. Determine whether the function x is equal to x cos pi x over 2, 0 lesser than x lesser than or equal to 1. 0, x is equal to 0 is a function of bounded variation on 0, 1. Question number 9a. If a series summation fn converges uniformly to f on a, b and each fn continues on a, b, then prove that f is integrable on a, b and the series summation integral a to x f and dt converges uniformly to integral a to x f dt for all on x belong to a, b, that is integral a to x f dt is equal to summation n is equal to 1 to infinity integral a to x f and dt for all x belong to a, b. B. Show that the sequence f and curly bracket, where f and x is equal to x over 1 plus n x square, x being a real number, converges uniformly on an interval I. Page 2 of 2.